Chapter. The last speaker for this seminar, Professor Andy Kafiul Israel from Independent University, Bangladesh. And the topic he's going to share with us is use of spontaneous blinking for application in human authentication. So Professor Israel online now?
Yeah. Hello, Prof.
Okay,
good afternoon from Bangladesh. Can you hear me?
Let's welcome Professor Israel. Please go ahead. Thank you.
Thank you. So let me share my screen. Hope that you can see the screen.
Yeah, we can see it. Okay.
Thank you. So thank you for the opportunity for the speech. I'm Mohammad Kafiul Islam, Associate Professor, Department of Electrical and Electronic Engineering from Independent University, Bangladesh. I'm also the Director of the Biomedical Instrumentation and Signal Processing Lab at this university. So the topic that I'm going to cover today is the use of spontaneous eye blinking for human authentication application. So basically, if you go to the background of this motivation of this talk, basically this is one of our articles that were published in 2020 in a journal, an elsewhere Q1 run journal. And this is basically what we're going to present today on behalf of all the authors. So this is the brief outline of the presentation. Moving on. So if you can see the human authentication system, there are different types of authentication systems, and we all know that the different applications that are for this kind of authentication. So we can have an authentication technique which is based on knowledge. Sometimes we can have an token based like the RFID card reader, or biometric based or recognition based. Now among them, biometric and recognition, like facial recognition, these are more secured in terms of human authentication. So among the biometric authentication, there are different types of authentication, including retina identification, voice identification, fingerprint identification, and so on and so forth. So although these are very biometric authentication are more secured, however, they are very complex in nature. And sometimes some of the biometric authentication can be made fake or tampered. For example, fingerprint. You can actually tamper the fingerprint from the others. So the objective of this particular topic or speech is basically we wanted to develop a robust but a low complexity human authentication system that cannot be made fake. So therefore, we thought that our eye blinking, the spontaneous eye blinking that we have, do we have different patterns for different persons? So this is the question that we wanted to ask, and then we proceed. So before we proceed to the experiment setup and the results, we'd like to understand what is EEG and what is eye blinking. So what happens, EEG is nothing but an electroencephalography, which is the recording of the brain's spontaneous electrical activity over a period of time by placing metal disc electrodes on top of your scalp. So it has basically two different types of parts of the EEG. One is the EEG background rhythm, and which is the different non-overlapping frequency bands. And then there are some transient events such as epileptic seizure or some artifacts like eye blink. So during EEG recording, the eye blink are considered as artifacts or non-neural source, or some kind of noise that is not very useful for EEG analysis. However, in our topic, we actually extracted this not so useful eye blink artifacts from EEG, and we made use of them to identify different persons. So we can see that when the EEG is recorded, there can be different eye blink artifacts on different channels. So these artifacts are often, because these are eye blinks, that means generated from the frontal channel of the frontal lobe of your brain. And therefore, you can see that eye blinks are often found in the frontal EEG channels. So what we say is that although EEG recording itself is a multi-recording, multi-channel recording, but we can only use the FP1, for example, one channel that is in the frontal lobe to extract that eye blink. And this eye blink has a different characteristics, and we would like to exploit these characteristics or features to see that if we can differentiate between different persons. So this is the proposed system that we had. We said that, okay, we'll record EEG, but we'll not use EEG basically. From EEG, we will extract the artifact eye blink from a already available open source toolbox like Blinker, which is an EEG lab compatible toolbox. So we extract the eye blinks and its features from the Blinker software, and then we use that features to classify different persons. So we'll go to the next page where we'll talk about different subjects that we have used for this experimentation, and then we'll try to classify. And overall, this is basically the process flow of how the Blinker tool will extract different eye blink features from the EEG recording. So I'll not go into deep on this technical detail. This is the process flow. So we can see that this is an example eye blink, extracted eye blink from the EEG signal and some of its features. For example, the peak of this blink, the left base, the right base, and so on and so forth. So basically, we'll extract 25 of some of these features from the extracted eye blink signal. So we had basically two different setups. Now, mind you that the original purpose of recording in these two different experimental setup was not actually to use the eye blink. It was for different EEG application purpose. For example, one of them was actually we're trying to find out if the subjects, we can identify the subjects if they're watching a video, then we can identify whether their emotion, whether they feel good about the video or bad about the video, or they were happy or stressed by watching the different types of video. And then there was another task where the subject was asked to like or comment, like or dislike, for example, in a series of different images shown on the computer screen. So basically that is an application for neuromarketing. So these two, when the subjects were recorded, we had no idea that we would be using these some of these data of this recording to identify these subjects individually. So originally, it was not intended to the biometric authentication of these subjects. Rather, it was used for two different EEG applications. However, we found that, okay, we had 46 subjects, and obviously each subject had a spontaneous blinking and pattern during the recording of the EEG. So why not try to identify those blinking, spontaneous blinking, because spontaneous blinking is something that cannot be made fake. And let's see that if we can classify between these subjects. So 46 subjects, from each subject, we had only used FP1 EEG channel, that is the frontal and parietal channel FP1. And then we extracted 25 features from each of the eye blink, and then we fed into a different classifier. So this is the process of the EEG recording during like and dislike comment of the neuromarketing experiment. So the experiment was intended initially for a different purpose, but later we used the same data, but not EEG. We extracted eye blink from the EEG to identify these persons. So we found that from the 25 features, we wanted to has more importance in terms of the classification. So we had this kind of analysis, the variable importance. And we also try to find out, let's say that we select 6 randomly subject, and we try to find out the amplitude of positive peak. And we did different types of analysis. This is another statistical analysis where we wanted to find out the distribution of the 4 most important features for 10 randomly selected subjects. And so these are some of the p-value of these features, trying to understand what's going on. But later, when we use 6 different classifiers, the classifier results were not very good. Initially, the SVM, random forest, KNN, MLP, Gaussian, and LDO, all these machine learning classifications, they had an highest accuracy around 55% maybe, or 50. So it was not good. Later, we said that, okay, we want to have an gated recurrent unit neural network to see that if we have a better classification. And then for different layers of neural networks and different number of blinks, we try to find out the accuracy. And we found that with the 8 blink features, 8 number of blinks, 8 for each subject, and 3 hidden layer, we found that the maximum accuracy is around 98.5%. So we selected GRU as our classification technique. So these some of the impact of the features and then values on the prediction accuracy, all 25 features. And then moving on, if we compare this with the other words, we found that the other words, they actually use this voluntary blinking signal. And we use only spontaneous blinking signal. And this blinking signal is only from a single channel, although the recording was done for a 614 channel emotic epoch EEG, but we only used FP1, only the frontal parietal channel, FP1 channel, to extract the spontaneous blinking. And we got an accuracy of 98.7%. So that means, and the number of subjects is also higher compared to the other works. And although Wu et al., they had a 16 channel, so they used all those 16 channels to extract features. So the idea is that we not necessarily need an EEG channel. We can have an EOG, electroocculogram, or that can a simple, analog front end to record the eye blink. Because eye blink recording is much easier than recording our brain signal. Brain signals are typically very low in SNR and very noisy. So that actually gives us the an opportunity that to use a low complexity hardware setup to record the spontaneous blinking and then use that blink signal to actually identify different people. So we had 46 subjects and we had a 98.7% accuracy find. So this is, in summary, we can say that use of spontaneous blinking signal for human recognition can be done, and with an accuracy of 98.7% that we have achieved. So we had total of 46 subjects, 25 features. We also tried to analyze the distribution of the variable, all the features. We found that the features are not distributed identically. We also found that several models were tested before, like SBM, ANN, and they did not come up with a good classification accuracy. However, we found that the sequence model, we found that the GRU has done a very good job with an accuracy of 98.7%. So in future, we'd like to replicate the same experiment with different tasks for the user, like reading, rest, and conversation, so that the user is not aware of that we are actually trying to extract their spontaneous blinking. Otherwise, they will have voluntary blinking as well. So we want to have a natural flow of this task, and then we want to extract the spontaneous blinking from that. Some of the selected references, and we'd like to acknowledge Professor Renato from Brazil. My first author, Mr. Amir Jalil Falad, thanks to him, and my colleagues from the Department of CSE at IUB and their lab for acquiring the second EEG dataset, and our lab, biomedical instrumentation signal processing, where one of my members currently present in this talk. Thank you, Sean, for being here. And last but not the least, my Department of Electrical and Electronic Engineering at Independent University. So I'd like to conclude here. Thank you very much.
Thank you, Professor Israel. Is there any question or comment from audience? No? Professor Israel, I have a naive question. Okay. Yeah. Is spontaneous eye blinking unique? I mean, for a person? I mean, that could two persons.
Turns out to be that, yes. Turns out to be that, yes, unique.
That is unique? I'm very surprised because, for example, you may, even though it is unique for a person, okay? Right. You may, for example, I may exhibit different spontaneous eye blinking when I face my mother's, and different from when I face my wife, right? So what happened to that situation? I mean, two different pattern of eye blinking come from the same person. How can you recognize the person?
Yeah, so initially we thought that, yes, the spontaneous eye blinking, how can it is different? But we found that, with the help of this advanced neural network, classification technique, we found that there is always a hidden features that we cannot understand from, naively, right? From apparently it seems that how can it's possible, but it turns out to be that we had actually classified 46 different subjects based on their eye blinking, and we took for each subject we have taken 8 eye blink, and they were all spontaneous activities because the subjects were not aware that will be extracting the eye
Mhm.
blinking. Okay, so they were
Okay.
actually doing other tasks like watching videos, watching some images to like or dislike those images. So yeah, so it turns out to be that. So basically, in order to make sure that it is robust, we have to replicate the same experiment for different types of tasks. For example, reading as mentioned in a future work. So then we can
Okay.
actually say that, okay, for different tasks, still the pattern of the eye blinking for different individuals is different, and that can be recognized and classified. Thank you.
So my wife cannot tell what I think by my eye blinking. Okay.
Yeah, that's
because she's always fixed.
because it's spontaneous, Professor. For example, your EEG signal, we can also identify individuals based on our brain signal.
Oh, I see. Okay. But how do you define spontaneous?
Yes.
For example,
voluntary
talking to a person
eye blink.
is not spontaneous.
Exactly.
If I talk, for example, I'm talking to you, it's not spontaneous, right?
No. I mean, when you because there are two different types of eye blink that we have, right? We usually have voluntary eye blink and spontaneous non-voluntary, right? We always blink, and we are not aware of these things, right? Without blinking, we cannot survive. So when we blink voluntary, the amplitude, the strength of the signal is higher than the spontaneous or non-voluntary blink. So this is how we can actually classify spontaneous and voluntary. Yeah.
All right. I got it. Thank you very much. Your talk is very interesting, and I think it's very practical for our use. Okay. Thank you very much.
Thank you for having me here. Thank you very much.
Thank you. So this is the end of this seminar, and I'd like to appreciate your attendance from my distinguished speakers and also audience. Thank you.
Okay.